Friends, welcome to this channel, Dr.ARM's Chemistry. We were discussing the organometallic compounds, and from last two periods lectures, we were discussing the brief history of organometallic compounds. And in continuation with this, today we will see the next development in the history of organometallic compounds. In 1972, the Heck, R.F. Heck, in 1972, the scientist R.F. Heck and T. Mizuki in 1972, R.F. Heck and T. Mizuki discovered the palladium catalyzed substitution of vinylic hydrogen by aryl halides. Discovered palladium catalyzed substitution of vinyl hydrogen atoms with aryl halides, which opens up the diverse palladium-based catalysis reactions in organic chemistry. So this provided an important tool for the reactions of organometallic chemistry. In 1973, another scientist, E.O. Fisher prepared the first metal carbene complex. Prepare the first metal carbene complex. The structure is like this. So here this chromium carbon triple bond, that is carbene, is prepared for the first time by E.O. Fisher. In 1973, the Nobel Prize was awarded to E.O. Fisher and Wilkinson. Nobel Prize was awarded to E.O. Fisher and Wilkinson, G. Wilkinson. application for their work on metal sandwich compounds, or their work on metal sandwich compounds such as FeCP2 means this cyclopentenyl ion, which has cyclopentenyl two ligands which are both connected to iron. Means iron is sandwiched between two cyclopentenyl units. So next, in 1976, MF Laporte prepared the first main group metallines, bimetallines. Prepared the first main group element dimetallines by making the first tin double bonded compound such as Me3Si 2 CH twice SN double bond CH Si Me3 twice. In 1979, Suzuki and Miura published their first paper on Suzuki coupling. Their first paper on Suzuki coupling of allyl boronic acids. Using palladium catalysts. Catalysts. For example, the reaction is like this. The reaction is carried out in presence of a palladium catalyst, PD, triphenylphosphine tetracase triphenylphosphine palladium, and K2CO3. So it gives the coupling of these two phenyl rings. So here we can say R is any substitution, alkyl substituted these rings. In 1980, Walter Kaminsky and Walter Kaminsky made zirconocene based catalysts exclusively for iso and syn diotactic polypropylene for such the zircon based catalysts are like this. This is one, and another is So these are the zircon based catalysts which are exclusively used for iso and syntactic propylenes. Iso means the propylenes which are having the substituents like phenyl on one side of the backbone, and syntactic propylenes have the substituted phenyls or bulky groups on both sides in alternate way. Such compounds can be prepared very easily with better yield. In 1981, Robert West made the first stable compound having silicon double bond. The first compound having silicon double bond, that is 1,3,5 trimethyl M3 6H2 4 Si2. So 1,3,5 these are trimethyl which are substituted on this phenyl ring. So these four groups are attached to silicon and there is double bond between two silicon atoms. In 1990, Richard Shock discovering molybdenum based catalyst, discovered a molybdenum based catalyst for olefin metathesis. And the structure of this catalyst is like this. Molybdenum, here's the 6H5 means the isobutyl group, like this. This is the structure of molybdenum based catalyst which is used for olipid metathesis. Again, in 1991, another scientist, J.M. Hawkins, J.M. Hawkins made the first fluorine-based organometallic compound. Made the first fluorine-based organometallic compound, which was also the first structurally characterized. Which was the first structurally characterized. Fluorine derivative. Derivative C60OSO for osmium tetroxide for tertiary butylpyridine. Later on, a host of organometallic compounds with direct metal carbon bond with eta2 bonding were discovered. So we will see the structure. This is C60 molecule, and of this benzene ring, this group of this carbon will be attached to oxygen, and this oxygen to this osmium, then double bond O. Here there is N. So since eta 2 bonding means the two bonds are attached to this oxygen, and this osmium. So these are called eta 2 bonding. In 1995, Robert Grubbs prepared his first generation ruthenium based olefin metal. Prepared his first generation ruthenium based catalyst for based olefin is based catalyst for olefin metathesis. Now the first catalyst, ruthenium catalyst, is like this. Here C1 is cyclohexene. So tricyclohexene phosphine. So PCY3 means tricyclohexene phosphine. So assume double bond C is here important catalyst. This is first generation catalyst. Second generation catalyst is like this. So the first was C, now second. second generation catalyst. These are three methyl groups, 2, 4, 6, 68. Then this is Cl, one Cl, another Cl, and this PCY3 tricyclophosphine, and this double bond PH. So this is second generation catalyst. Second generation catalyst. Detected in 1997 when Cummins, C.C. Cummins, used carbon as ligand, that is carbido, showed the carbon atom, as a ligand, that is called carbido. In organometallic compounds, for example, R2N thrice MOC minus. So this carbon is in atomic state and it is used here as a ligand, and this carbon ligand is called carbido. So this is anion. So carbido molybdenum anion is the important discovery in which carbon is used as a ligand. In 1997, GM Robinson synthesized the new salt having gallium triple bond, synthesized. Sodium salt of this NH2AR. This AR means not argon, but it is aryl group. Aryl, gallium, triple bond, gallium, aryl. So here gallium triple bond is important invention in 2001 by Nobles, W.S. Nobles. Knowles. Who received the Nobel Prize for enantioselective metal catalyzed asymmetric hydrogenation? Received Nobel Prize. Nobel Prize for enantioselective metal catalyzed asymmetric hydrogenation along with this is work done by Knowles, and in addition to this, along with Sharpless, KB Sharpless and R. Noiri. The Nobel Prize was shared with these two, Sharpless and Noiri. Another scientist, Nakamura, in 2002. Nakamura prepared bulky ferrocenes. A molecular hybrid. Of ferrocene and fullerene by treatment of C60 HMe5 or C70 HMe3 with a free CP2, CO twice 2, CO2 twice. So this can be shown with the reaction. So Nakamura prepared bulky ferrocenes. It is a molecular hybrid of ferrocene and fullerene by treatment of C60HMe5 or C70HMe3 with ABCP CO twice. Now the reaction is like this. So this is our fullerene, and it has the bonds like this. This is Ime, this is Ime, here is hydrogen, and this compound reacts with Fe CO So this is our catalyst. So it is prepared with PHCl at 180 degrees centigrade and 8 hours for 8 hours reflux. Then we get the new compound pair. So we will use the same structure to show here product. So this will bound with Fe this way, and the neighboring benzene ring will show the methyl groups like this. Methyl groups. There is one methyl, and this is one methyl group here, and these two methyl groups in like this. So here this cyclopentadiene ring is attached to this Fe. Means here we have obtained the hybrid between the cyclopentadiene and this fullerene. Structure of this fullerene ring can be drawn in this way. So in order to remember the shortcut, first order is 5-membered ring, then surround this 5-membered ring with 5 benzene rings. These 5 benzene rings, and these are further surrounded by alternate 6-membered and 5-membered ring structures, alternate structures. So you will get this fullerene. So in this way, just remember this trick, how to draw the structure. In 2004, a Sekiguchi prepared the first silicon-silicon triple bonded pair. The first silicon-silicon triple bonded molecule and carried out its structural characterization. And carried out its structural characterization. The molecule can be drawn in this way. Na3Si, Na3Si. HC. Then here isopropyl group. Then again here same CH Ma3 Si twice. 3 Si twice. Then this is further bonded to Si. Here it is Si triple bond, and then again this is further bonded to Si. Here we get this CH Si Ma3 twice. Then isopropyl group. Then this CH Si Ma3 twice. So this triple bonded structure is the important part of this molecule. So second, to prepare this first silicon triple bonded structure molecule, and also characterize the molecule structure. 2004 Carmona, Carmona prepare the first zinc organometallic compound. Prepare the first zinc organometallic compound. Prepare the first zinc compound. So shortly it is represented as Zn CP2, Zn CP twice. So it is having cyclopentadiene groups which are substituted. So the structure can be drawn in this way. So it has the cyclopentadiene groups Zn, here it is Zn, two Zn atoms. It's dimethylene compound. In 2005, then Jewish Chori, then Jewish Chorin, CHA Chorin from France. Then another Robert Grubbs, Robert H. Grubbs from Celtic, and Richard Shock from MIT, USA, received the Nobel Prize. automobile drives. For olivine metathesis, or olivine metathesis, that is C double bond C. In 2005, heat power prepared the first stable organometallic compound having five-fold bonds in spin to plate. Prepared the first spin to plate bond, that is stable compound with a possible spin to plate quintuple, so we can say quintuple bond, that is five-fold bond between metals, between metal. Where there is aryl groups and chromium, like this, chromium aryl group. So there are five bonds, means 1 sigma plus 4 pi bonds. In 2006, Peter Vallard, in 2006, Peter Vallard, here it is, prepared the so-called impossible structure, that is hexacyclopentase, that is hexaferrocyanine benzene. Prepared hexaferrocyanine benzene. So if we show this structure like this, say this is our benzene, and here we can have these five substituents which are cyclopentadiene. 6 cyclopentadiene groups which are substituted and 6 carbon atoms of benzene. So it is called hexadenine benzene. So such structure was considered or thought to be impossible in 2010. In 2010, Nobel Prize was awarded to Richard Hick. Nobel Prize was awarded to Robert E. Hick. Robert E. Hick. Then Alici Negishi and Akira Suzuki for their research contribution in palladium catalyzed cross-coupling reactions in organic synthesis with incremental innovation to the breakthrough discovery for their research contribution in palladium catalysts catalyzed cross-coupling reactions in organic synthesis. Where incremental innovation to the breakthrough discovery. So this is the recent discovery in our important historical evidence or event in the organometallic chemistry. So with this we have completed the point, that is brief history of organometallic compounds. So with this stop our discussion here. If not subscribed yet, please subscribe to this channel and also press the like button. So thank you very much. See you next time in the next point of this topic.